Hi everyone, this lesson is for geometry students. This is chapters 5 and 6, part 2 of our test review, and this is a practice test. So let's get started. The first question that we're going to see is which of the following cannot be used to prove the congruence of two triangles? We set side angle side, completely fine. Side side side, completely fine. Angle side angle, also fine. So these three are all good. This one definitely you would not use because, and the reason why you would not use angle, angle, angle is because in order to prove two triangles congruent, you need at least one side. And here we have three angles, two angles, you automatically have the third angle, which is used to prove that the two triangles are similar but not congruent. For this triangle here, we have triangle XYZ, and XY is equal to YZ. So I'm going to say X is here, we have Y, and then I'm going to say Z is down here. It says it's isosceles. XY is congruent to YZ. Therefore, what statements must be true? Well, what you do know is that let's see, if you have two congruent sides, then the angles opposite those sides are also congruent, which would mean this angle here, which is opposite this side, is going to be congruent to this angle, which is opposite that side, because of those two being congruent. So you would say that angle X is congruent to angle Z, and because of the isosceles triangle theorem. In PQR, which side is opposite of angle R? So we'll just say P, and we have Q and R. So what is the side opposite angle R? Well, here's R. So the side opposite that, not touching, away from, would be segment PQ. And this one. So for this problem here, it says you have triangle LMN. So L, M, and then N. It says that L is greater than 90. So I'm going to call it 91. Angle M and N are equal, so they are the same measure. So what kind of a triangle is it? Well, I know the sum of these two angles is 89, and we would split that up because they're congruent. It would be isosceles, because if the angles are the same, then the sides are the same. That means it's isosceles. And anything greater than 90 is going to be obtuse, so I would say D. For this problem here, it says M and O, so I'll say M, we have N and O, and then we have R, we have S, and we have T. So for M, N, O, and R, S, T, if angle N is congruent to angle S, and we know that angle M is congruent to angle R, well, that would make M, N, O equal to ST. That's not an option. It would make, if N is congruent to S, MO congruent to RT, NO congruent to TR. That's not true. Angle O would have to be congruent to angle T. That's what we know, because any angle that you know, you've got two angles. The third angle has to be congruent, meaning you could plug any number in. Like, let's say this is 90 and this is 90. And then this is, let's say, 30, and then that's 30. Well, this would automatically have to be 60, okay, because they're just what's left in that angle. So you would say these two. You need more information to prove that the triangles are congruent. So you can just say that the angles are congruent. For PQR, so here we go again, PQR, and then we have D, and then E, and then F. It says then RP, oh, these are congruent. Then line segment RP is congruent to, see, RP should be congruent to FD. So FD. You don't really have to draw them out. You can just look at the segments on here. So I'm looking for RP is congruent to FD, and so that would be this one. In triangle RST, so here's R, here's S, here's T, and we have H, and then I and J. It says the measure of angle R is 97 degrees, and the measure of angle J is 37. So S is equal to 4x plus 14. So what you need to know is that if two triangles are congruent, then all their parts are congruent, meaning that's 97, that's 97. If this is 37, this is 37. If that's 4x plus 14, so is this. But in order to find the value of x, I'm going to take all three of my angles, add them up, and set them equal to 180 degrees. So I have 97 plus 37 plus 4x add 14. And let's see, let me move these apart a little bit. And so I'm going to use my calculator. I'm going to go 97 plus 37 plus 14 is equal to 148. So I have 100. So I have 148 plus 37 is equal to 180. I'm going to subtract 180 and from 180 and I get 32. Where's my x? 148. I just lost my x. Hold on. Let me go back. All right. Oops. Oh, for heaven's sakes. We had 97 plus 37, so that goes here, plus 4x plus 14. All right, let me do that again. 97 plus 37 plus 14 is 148. And 148 plus 4x is equal to 180. And if I take 180 and I subtract 148, I get 32. And so I have 4x is equal to 32. So x equals 8. And so that's all they wanted you to do was find x. For this problem here, we have three different triangles. And you actually don't need to draw this out because it says that triangle ABC is congruent to DEF. What that means is every part of ABC is going to be congruent to DEF. So that means A is going to correspond to D, B is going to correspond to E, and so on. So what then it says is, and then those triangles are congruent to GHI, which then everything there corresponds. So if I'm looking at AC, so here's A and here's C. What must be true about G and I? So here's G and I. Well, those are going to be the same lengths because they line up, they correspond. And if two triangles are congruent or three triangles are congruent, all of their corresponding parts are also congruent. For this triangle here, it says name one additional pair of corresponding parts that need to be congruent in order to prove that FIG is congruent to TOM by side angle side. Well, in order to prove that the two triangles are congruent by side angle side, you need to notice that the angle in between the two sides, the angle is in between the two sides that are congruent. So in this case, I've got this angle here and this angle here. And what that means is that I need another side on the other side of that angle, which means that IG, segment IG, needs to be congruent to segment OM in order for me to say that the two triangles are congruent by side angle side. For this problem, it says the measure of a base angle of an isosceles triangle is 52. Well, a base angle is on the bottom. That's a base angle. This up here, that's called my vertex angle, or my vertex. And so that's not my base angle. So I've got 52 here, which is the same thing as 52 here. What is the measure of the vertex angle? Well, all I have to do is add 52 plus 52. So 52 times 2, right, is 104. So we've got 52 plus 52 plus my vertex angle adds all up to be 180 degrees. So I'm going to take 180 degrees and subtract 104, which is 54 plus 54. So my vertex angle is going to be 76 degrees. Okay. The next question says, determine which triangles in the figure are congruent. If angle BAE, so this angle here, is congruent to BCD, so this isn't congruent to that. BD, this segment, is congruent to BE. Cool. All right, so what you can do, one of the things you can do, is you can prove that you have two separate triangles. There's a lot of different options here. I like this option here with this, saying that BAE, let's see, ABE and CBD are going to be congruent. You can't really say that ADC is congruent yet because you would have to say then, there's other things, but you don't have enough information based on the information they gave you, which is up here. ADF, let's erase some of this. ADF is this little triangle here, which again doesn't deal with the BD. And then you've got ABC, the whole triangle is not congruent to AFC, so that's definitely a no. For this problem down here, it's saying given the figure ABC and DEF are congruent, and they're right triangles. They're right triangles. AC is congruent to DF, which is enough to prove that the two triangles are congruent. I would need more information to prove that the two triangles are congruent, because right now I just have a leg and a right angle. So option A would be, I could say AB is congruent to DE. I could say this is true. They would be congruent by what we call HL, hypotenuse leg. So we've got our hypotenuse and our leg. If I then, instead of saying DE is congruent to AB, knowing that AC and DF are congruent, I could say that BC is congruent to FE, BC and FE, which I don't have that option. It's none of my options. So therefore, the only one that would work in this case is that AB is congruent to DE, and that would be by hypotenuse leg. For this problem, it says a right triangle has one leg with measure of 7. So we have 7, and we have a right triangle. Another leg of 8. So these are my legs. The legs are not the hypotenuse. The hypotenuse is here. What is the length of the hypotenuse? Well, you're just going to use Pythagorean Theorem. That's all. And so we're going to say 7 squared plus 8 squared is equal to h, which is my hypotenuse squared. So we're going to go 49 plus 64 is equal to the hypotenuse squared. And so 49 add 64 is going to give me 113. So my hypotenuse is going to equal to the square root of 113. What is the length of the hypotenuse? I think these all have to be rooted. So that's going to be B if it was a root. Find the length of the missing leg in the triangle. Well, what I want to make sure that you all remember are your Pythagorean triples. And those are the right triangles that are most commonly used, such as 3, 4, 5s, 5, 12, 13, 7, 24, 25, and the last one, which is 8, 15, 17. So, and then of course you have the ones that are like multiples, like of 3, 4, 5, for example. If I multiplied by 2, some of you may recognize 6, 8, 10. If I multiplied by 3, I would get 9, 12, and 15. So there's definitely some familiar ones that we see more often than others. But for this one right here, you definitely can use Pythagorean Theorem, right? You would say 5 squared plus x squared is equal to 13 squared. And of course, you would get 12 because you should recognize that it is one of our triples. The length of a rectangle is 6 centimeters and the width is 3 centimeters. Find the length of the diagonal, which is this corner to corner line, and so segment. And so we're going to use Pythagorean Theorem again. And so we're going to go 6 squared plus 3 squared is equal to x squared. 36 plus 9 is equal to x squared. And so I'm going to get 45. And 45 equals x squared. So x is equal to the square root of 45. And what that is going to give me, I'm going to reduce that by 9 times 5. 9. So that's going to be 3 root 5 centimeters. And I definitely think this has a little bit of an issue with losing the roots when it printed. But this should be 3 and then root 5. For this problem here, it says the perimeter of a square is 20. So what you need to remember is that a square has 4 equal parts. And all 4 equal parts, right, have the same measure. So if I know that the perimeter all the way around my square is 20, if I divide 20 by 4, I'm going to get 5 centimeters for each side. Find the length of the diagonal. Again, I'm looking for this side, but in this case, this is a 45-45 special right triangle. And yes, you absolutely, in order to find this diagonal, which I called x, you can use Pythagorean Theorem, which is 5 squared plus 5 squared is equal to x squared. So I've got 25 plus 25, which is 50, is equal to x squared. So x is equal to the square root of 50. And so in doing that, I know that that's going to be root 25 times root 2, which is 5 root 2. So I know that this value here is 5 root 2. Now that's one option, is to do that the longer way, of course, but because it is a special right triangle, whatever this value is here, this is x, and then this is x root 2. So if this was 10, that would be 10, and this would be 10 root 2. So definitely, good to know that shortcut. For this problem, it says the perimeter of an equilateral triangle is 15. So again, equilateral means all 3 sides are the same value, the same length. And so that means that all 3 of my sides have a measure of 5. Additionally, all my angles have to be 60 degrees, because if it's equilateral, I'm going to take 180 and I'm going to split that by 3. Now, an altitude is going to come perpendicular straight down and cut this base into 2 equal parts. Okay, this happens on an isosceles triangle and an equilateral triangle. And it comes down perpendicular. So now this part is 2.5, just this length right here. Now remember, across from the 30 is our A value. Across from the 90 is twice A, which means A is 2.5. And then across from the 60 is our A root 3, or 2.5 root 3. And so that's that value of my altitude. So I've got 2.5. So I've got 2.5 root 3. So 2.5 root 3. And you definitely can simplify that a little bit, right? So you can say, and make that into not an exact value. So the square root of 3 is like 1.7, and if I multiply that by 2.5, I get about 4.3. So if they ask me for an exact value, this would be my answer. But if they ask me for an approximation, it's going to be about 4.33. That's my, answer approximated. For this problem here, it says in the figure to the right, you've got the measure of angle x is 42 degrees. xz is 35. Find the value of A. Well, I'm going to put myself right here. And in doing that, I see that this is my adjacent side and this is my hypotenuse. If you remember from your mnemonic, which is SOHCAHTOA, you've got sine of an angle is equal to the opposite side over the hypotenuse. Cosine of an angle is the adjacent side over the hypotenuse, and tangent of an angle is the opposite side over the adjacent side. So in this case, I don't have the opposite side here, so I'm not going to use anything with opposite. I'm going to use cosine because that uses the adjacent side and the hypotenuse. So I'm going to say cosine of 42 degrees is equal to my adjacent side, A, which I'm trying to find, over my hypotenuse, which is 35. I'm going to cross multiply. I get A times 1, which is A, equals 35 times cosine of 42. And so cosine of 42 degrees is about 0.743. And I'm going to multiply that number by 35. And I'm going to get about 26. So A is approximately 26.01, so about 26. For this problem, it says triangle ABC. So ABC is congruent to X, Y, and Z. And make sure that you take the time to line everything up. Because if A has to correspond with X, B needs to correspond with Y, C needs to correspond with Z. And yeah, these need to be capitals. Okay, AB is 38, so that value is 38. And YZ down here is 28, which if the two triangles are congruent, so is this. And XY, which is this left side, is 5x plus 8. So realistically, what we know is that this side equals this side is equal to this side, and that side equals that side. So I just want to find the value of x. So I can set 38 equal to the side that's congruent to it. So 38 equals 5x plus 8. I'm going to subtract 8. I get 5x is equal to 30. Divide by 5, I get x equals 6. And so the value of x is 6. Aaron is flying a kite on a 40-meter string. So we're going to say the kite is, let's say, up here. And then this is the string kind of pulled taut. And that's going to be 40. It says the angle of elevation, which is always from the base going up. So the angle of elevation is 35 degrees. We have, this is our height, which is perpendicular. Aaron's hand is 1.8 meters above the ground. So that distance is 1.8, which is going to be the same as this distance. How high is the kite? Well, I'm going to find this value x, and then I'm going to add 1.8 once I'm done. I see I have the opposite side here, and I have the hypotenuse. And in order to use that, I'm going to use sine. So I'm going to go sine of the angle, which is 35. You always put the degree after the word, sine, cosine, or tangent, is equal to the opposite over hypotenuse. I'm going to cross multiply. I get 1 times x, which is x, equals 40 times sine of 35 degrees. So I have 35, well, I need to do sine of 35, make sure you're in degrees, is 0.5735. Take that number, multiply it by 40, and I get about 22.9. So x is approximately 22.9, and this is meters. So this is about 22.9. So don't forget, you need to take your 22.9 and add your 1.8. So x, or the height, is going to be x plus that 1.8. So we've got 22.9 plus 1.8. So the height is approximately, because we did round, it's approximately 24.7 meters. So that's a pretty good height for a kite, right? The measure of an isosceles triangle, the measure of the sides are 21, 21, and 8. So 21, 21, and 8. So it's isosceles. Find the measure of the base angle. So I could left or right, pick one. I'm going to call that theta. And what I'm going to do is I'm going to bring this straight down perpendicular because in an isosceles triangle, what that does is this divides this length into 2 equal parts, which now I have 4. So if I want to find the measure of the base angle, I need at least 2 pieces of information. So now I have this 4, which is adjacent. So if you put yourself at that angle, right, you're here. This is the hypotenuse now because this is a right angle. It's not a 30, 60, 90. It's not a 45, 45, 90. It's just an angle you're trying to find based on 2 sides that you're given. And so this is the adjacent side from where you are, and that's the hypotenuse. So what uses the adjacent side and the hypotenuse? Well, cosine. And so we're going to say cosine of the angle is equal to the adjacent side over the hypotenuse. Now, your job is to solve for theta, the angle. And in order to find the angle, you need to take this cosine and you need to move it to the other side of the equation. That act of moving it over is the inverse, but we actually call it arc. Arc cosine. You say the whole word even though you're writing 3 letters. So we're going to say arc cosine of 4 over 21. So theta is going to be about, because I am going to round, use your calculators, you guys. You got to go second cosine. So that's the arc cosine, that inverse function, is above the regular cosine. So you're going to go 4 divided by 21, and you get about 79. So I get about 79 degrees. And so that's this measure of this base angle right here, 79 degrees, which this is also the same value. So that's it. That was, not too shabby as a practice review. You have an exit ticket number 9 that is due by the day of your test. And so I would expect that to be done by Wednesday. I wish you the best of luck on your exam. And thanks so much for watching. I hope it helped you.